Would you like to know the 4 approaches of a cloud disaster recovery architecture? If so, this video is for you. Hi, my name is Mike Gibbs, and in today's video, we're going to talk about the 4 options that you can typically use for cloud disaster recovery architectures. I will discuss all 4 options, and I will discuss the trade-offs of each approach. Now, I remember architecting disaster recovery situations prior to cloud computing, and it was much more complicated because we would have off-sites, we would have to stock it with some gear, have a supply chain to get additional things there, and it was fairly complicated. And if we wanted to have a really high-speed environment, it was incredibly expensive. But cloud computing gives us an incredible architectural set of options for disaster recovery. And we don't have to necessarily buy gear ahead of time. We don't even necessarily have to pay almost anything, depending upon our environments, ahead of time. So cloud computing gives us some incredible disaster recovery options. Now, the first disaster recovery option we're going to talk about is what's going to be called backup and restore. And in a backup and restore environment, what we typically have is we have either our data center or a cloud provider, it doesn't matter, and we're going to do a backup of our system and our system images to a cloud provider. Now, realistically speaking, you really don't want to back up your same cloud provider to another part of the same cloud provider, because if something big happens to that cloud provider, it could potentially affect all the regions and all of their availability zones. So backing up to the same cloud provider is a bit risky. So typically speaking, you should back up to another cloud provider if you're looking for high availability performance. But what's really going on here? Typically speaking, what we have is we have our, let's say we've got virtual machines and whatever running in this data center. We're going to have an image of those same identical systems in the cloud. And that way, all we really need to do is take those images and turn them on as virtual machines in the cloud or whatever we need to, images of whatever system, and they're up and running in the backup cloud. And typically, we're going to have backup data here. Now, this, all in all, is very inexpensive because we have backups of our images and backups of our data. Now, the problem here is while it is very inexpensive and it is very simple to set up, it typically could take the longest amount of downtime to get this system up and running. It's not going to be a situation where we get it up and running. Now, it gets easier when we have infrastructure as code scripts that'll launch all these systems and we can take our information from backup. But we have to understand this is not this of all of our architectural options. So when would we use something like this? For non-critical systems, for cost-sensitive workloads, any kind of environment where we can tolerate a lot of downtime and even some data loss without having any problems. So that's the backup and restore approach. Now, the next approach I'm going to talk about is what's called pilot light. And this is kind of actually interesting. And I'll show you what that is architecturally speaking. In the pilot light approach, what we're actually doing is we're basically keeping our systems images just like we did in backup and keeping our actual backups of most stuff going on. But what we're doing is we're synchronizing our data tier. It could be our databases, it could be a few data-oriented services, but what we have here in this particular environment is synchronized data between the data center and ideally a different cloud provider. Now this balances cost and speed because we don't have any old data here. So we can actually get this system up and running faster. It's a lower rebuild risk than the backup and restore that we talked about before. But it's still not going to be the fastest thing to get up. And this is great where you've got a business app, but that's important where you don't want to lose any data, but it can go down for a couple hours and everything is okay, several hours or more. So we talked about that pilot light approach. Now, where it gets really interesting in cloud computing is when we get to warm standby. And this is a fascinating option that we never had prior to cloud computing. And effectively in this warm standby, we've got an active full-size environment and then a minimal environment. And I'll show you what I mean. So let's say this is our data center or our cloud. It doesn't matter where we are at. So let's say in our primary cloud, we have 10,000 virtual machines going on at any one time across, say, 100 different applications. It could be anything that we have running. I'm just going to pick virtual machines for simplification purposes. So if we've got 100 applications running for 10,000 virtual machines, what we would do is we would have a small version of every application sitting in an auto-scaling group. And what we would ultimately do is we would have our data tier constantly synchronized. So what we have here is a small replica of our entire big version. And why does this work? See, what happens is in the event there's an actual failure, and what I maybe here is something were to go down here, the traffic will be shifted to the backup cloud provider. And as the traffic hits the cloud provider, it'll overwhelm the servers and their actual capacity. Auto-scaling will build it out to the full necessary capacity. And we will be completely up and running within, typically speaking, 45 minutes or less. And this can be great for this. Now, it's obviously higher cost to have small versions of your systems running 24 hours a day. But it gives us a somewhat cost-effective approach to organizations that need relatively that need some degree of either high availability or they need to be up and running should a major disaster occur fairly quickly. So this is a terrific environment for organizations that need that, but still don't need to spend a lot. We've got fast failover here. I hope that makes sense why. Minimal rebuild work, because for the most part, it's going to do it via dynamic auto-scaling. But higher steady state costs. And we have to be, the data, obviously the big concern is making sure that it's replicated properly. So pretty great environment for certain organizations. Now, what about when a business has such severe downtime costs? Businesses that lose $1 million or $2 million a minute. Businesses that are in a business where if the systems are down, someone can suffer negative consequences. That's where you start needing a different type of environment. And that's where we get to the active environment. And I'll show you what that actually means. No, I generally don't recommend running the active in different parts of the same cloud for the obvious reasons. If the cloud were to get taken down by a big network issue, a control plane attack, or for us, a cold control plane was down, a big DDoS attack, it could take down the entire cloud. So generally speaking, if you're going to go to this effort and this money, you probably want to be in another cloud. But here's your active. If we've got 10,000 servers at a certain capacity in the primary data center, we've got those same 10,000 servers active in the secondary cloud provider. Everything is synchronized back and forth at all times, which is great from an availability perspective. If this thing goes away, then the traffic is going to be very rapidly shifted to this other environment pretty quickly. So this is a very this is a very cost-ineffective approach, but it is a very high resilient approach, getting the business up and running almost immediately at capacity. So this is an environment where you need to be up and running in seconds to minutes. This is an environment where minutes cost money and serious money, that we're going to spend serious money to actually protect it, or we're protecting life for an emergency services system or a hospital system or something where it really, really matters. Constant disaster recovery, constant up to date, but lots of cost, lots of complexity along the way. So where do you use it? Mission critical environments. So there's lots of things. So I'll give you some general approaches to make a lot of these easier. Design with infrastructure as code and automation there. So we should have a failover and a build and fallback mechanisms that we could do if we needed to go on another cloud very quickly in the event we're not using an active or a warm standby environment. What we really need to do is not all workloads need to be hosted at the same level of availability from a cost perspective. So we might want to use a replication model per workload. Maybe some workloads have to be active and other ones do not. Something to think about. Now, whatever we want to do, we want to protect the control plane. We may not have complete control over the cloud provider's control plane, but we do have control over our part of the control plane. So we want to separate accounts, use subscriptions, least privilege, that kind of thing, immutable backups. And we want to prove that we're working often. So typically speaking, we may want a game day, we want to test, we want to make sure that everything is working as designed. So in this video, we discussed the 4 architectural approaches to cloud disaster recovery. We talked about backup and restore. We talked about pilot light. We talked about warm standby. And we talked about the multi-site active, hot, whichever term you approve. If you'd like to become a cloud architect or security architect or an AI architect or an enterprise architect, join us for a completely free architecture webinar. You can find the links to these free architecture webinars in the description of this video. Come sign up to any of our webinars. We'll tell you the skills that you need for your architect job. We'll tell you everything you need to do to get hired. And of course, you can ask me any questions live and free because these webinars are on Zoom. And I'll do anything I can to help you in your architecture career. So please join me. The link to register for any of these architecture webinars is in the description of this video. If you enjoyed this video, please give it a like, subscribe to our channel, and hit the bell to be notified of new videos to assist you in your IT architecture career, whether it be a cloud architect career or an enterprise architect career or a security architect career. And I hope to see you in another video or a free webinar where we can meet face-to-face and we can have a discussion. So in any case, take care, and I will either see you in another video or a free webinar.